Hello everyone. In this video, we will talk about the theorem ASA Congruence rule. This theorem states that two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. Now, we are going to prove this theorem using three different cases. So let's do that. So we have two triangles, triangle ABC and triangle PQR, in which it is given that two angles and the included side. So angle B, angle C and the included side BC, they are equal to these two angles, angle Q, angle R and the included side QR. So the given is now we need to prove using our previously proved theorems that these two triangles are congruent. Now we will use three cases. We will talk about this length of AB in relation to length of PQ. So what are the three cases available to us? 1. Length of AB is equal to length of PQ. 2. AB is smaller than PQ. 3. AB is greater than PQ. Is there any other condition? No. Either they will be equal or AB smaller than PQ or AB greater than PQ. So we'll use these three conditions and we will try to prove our theorem. Let's use first condition where AB is equal to PQ. So we are saying AB is equal to PQ. So if that is the case, then we see AB equal to PQ, that is assumption. Angle B is equal to angle Q and BC is equal to QR. This is given. And now we can see that if AB equal to PQ, angle B equal to angle Q, BC is equal to QR, then using the axiom SAS congruence rule, two triangles become congruent. So using our previous knowledge, using the axiom SAS congruence rule, now we can say that these two triangles are congruent. That's our case 1. Now let's talk about case 2 where AB is smaller than PQ. We are talking about case 2. AB is smaller than PQ. Now if AB is smaller than PQ, then we will have somewhere on PQ there will be a point P dash such that P dash Q is going to be equal to AB. That's because of our assumption and construction. So now we have this triangle P dash QR in which AB is equal to P dash Q. Now we also know that angle B is equal to angle Q. That's given. And BC equal to QR, again given. And therefore, using the SAS axiom, we can say triangle ABC is congruent with triangle P dash QR. Using CPCT, angle C is equal to angle P dash RQ, that is by CPCT. But we say angle C is equal to angle R, and angle C is equal to angle P dash RQ, and therefore angle R is equal to angle P dash RQ. C equal to R, C equal to this, that means R is equal to this. But that can only happen when P dash coincides with P. Otherwise, it is not possible. These two angles cannot be equal unless this P dash point is same as point P. And which clearly indicates that from this, P dash has to coincide with P, and that means triangle ABC is congruent with triangle PQR. So P dash has to be equal to P. The theorem is true for case 2. Now let's talk about case 3. So case 3, AB is greater than PQ. So AB is greater than PQ. That means there must be some point here A dash such that A dash B is equal to PQ. Isn't it? Because if AB is greater than PQ, PQ is smaller than AB, that means some point here A dash B, which will give us the exact length of PQ. And let's draw A dash C. And now we can see that A dash B is equal to PQ. That's our assumption and construction. Then we know angle B is equal to angle Q, and we also know BC is equal to QR. These are given. And from these three informations, we know that triangle A dash BC is congruent with triangle PQR using the SAS axiom. Side, angle, side. Now, once we prove that they are congruent, that means their corresponding elements also are going to be equal. And that clearly indicates that angle A dash CB is equal to angle R. CPCT. But here we see angle R is equal to angle C. That means angle A dash CB is equal to angle C, because angle R and C are same. That's given. And now we see that this angle is equal to this angle C. But that is not possible unless point A dash coincides with point A. When point A dash coincides with point A, that is possible. But that is a given, so it has to be possible, and then that clearly means our point A dash is coinciding point A, and which clearly gives us that if we have two angles and an included side equal to the two angles of the second triangle and included side, then those triangles are congruent. And that's our theorem about ASA congruence rule. And let's see the theorem once again. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and included side of the other triangle. In our next video, we will do a few practice sums related to the axiom and the theorem we have learned so far.
I am sure you have liked the video. Hit the like button and leave your views in the comment section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the QTube app at the link provided in the video description. Till we meet again, goodbye.